So moving ahead, the next topic that we are going to discuss is flow control, one of the very important function of TCP. This flow control is there in data link layer also, and it is there in transport layer if we are using TCP or HTTP. Now, in this class, we are going to see the difference between the flow control that was there in data link layer and the flow control of transport layer, as well as we are going to see how this TCP implements this flow control. Okay, so before understanding what is flow control, let us revise the concept of buffer in the network. Okay, now in the network you have the sender, intermediate nodes, and the receiver. Okay, so those intermediate nodes will be part of the network. Now all the node, okay, they are going to have a buffer, okay, wherein all the data will be stored. Okay, and then those data will be processed, then they will be forwarded towards the next node. Okay, in the sending side, like you have the application program which will be generating the data. Those data will be stored in the sender's buffer. Now sender process further will be processing those data which is there in the buffer, and then it will be transmitted through the network. Now, when the data is moving through the network, there will be intermediate nodes. Now, those intermediate nodes like router, they are also going to have buffer. Okay, so router is going to maintain two types of buffer. One is called incoming buffer, the other one is outgoing buffer. So every incoming packet, okay, from that interface will be stored in the incoming buffer. Now, from the incoming buffer, one packet will be taken at a time. It will be processed to find the destination, and then that packet will be stored in the outgoing buffer. Now, from the outgoing buffer, network will be carrying the packet and it will be forwarding to the next node and so on. Finally, the packet will reach the destination. Now, in the destination also, there will be a buffer wherein all the incoming packet will be stored. Now, the destination process will be taking one packet at a time. It will be processing to find the appropriate application program, and then the packet will be forwarded to the destination process. So here, all the node that is there in the network are going to maintain the buffer wherein all the packets will be stored. Okay. Now, the flow control is the speed with which the sender is transmitting the data should not be overwhelming receiver, as well as it should not be overwhelming the nodes of the network. Okay, that is, the rate at which sender is transmitting data should not be so much that the destination is not able to store in its buffer. Okay, that is, destination's buffer is full, so remaining packet, whatever it is getting, it will start dropping those packets. Okay, and as well as the rate at which the sender is transmitting the packet should not be so much that the intermediate nodes, that is the router, is not able to store in its buffer. Okay, they will not be able to store in their buffer is because their buffer is full. Okay, so every incoming packet, once the buffer gets full, they will start dropping. Okay, so that is called as packet loss in the network. Now, the flow control is one important feature is because if the sender does not monitor, okay, that the intermediate nodes, whether they are able to store in their buffer, as well as the destination, whether they are able to store in their buffer, if the sender is not able to monitor this, then there will be lot of packet loss. Okay, and more number of packet loss means sender will have to retransmit those packets more. So which means that there is going to be large number of packet communication, so which is unnecessarily going to use the resources of the network. Okay, now as I said, that flow control means that the speed with which sender is transmitting the data, it should not be overwhelming the receiver, as well as it should not be overwhelming the network. Okay, now how TCP implements this flow control is, again, the same concept is being used which was used in data link layer, that is the concept of sliding window. Okay, so here, as similar to that of data link layer, here also the TCP is going to use one imaginary window which is called as sliding window. So whatever data bytes has been covered by that imaginary window, those bytes only the sender TCP can transmit. And the sender TCP will be waiting until it does not receive the acknowledgement for those bytes. Okay, so once it receives the acknowledgement for the byte, the window will be moved towards right. Okay, it is going to move forward. That means it is going to include more bytes, okay, which will be eligible for transmission next. So that is why it is called sliding window. We will be elaborating this in detail in the further slides. Before that, let us see what is the difference between the sliding window of TCP and the sliding window of data link layer. In case of data link layer, this sliding window, which is an imaginary window, okay, was covering the frames of the buffer in the sender process. But in case of TCP, this sliding window will be covering the bytes in the buffer. That means the sliding window of TCP is byte oriented and the sliding window of data link layer is frame oriented. Now, another difference is, in case of data link layer, the size of the sliding window was fixed. Okay, let us say if the size of sliding window is 5, that means every time a process is allowed to transmit maximum of 5 number of frames. But in TCP, the size of the sliding window is variable. Okay, it is going to be determined by other parameters, and what are those parameters? Again, this also we are going to see in the subsequent slides. So the sliding window of TCP is of variable size and the sliding window of data link layer is fixed size. Now you can see here in this diagram, the application program will be generating the bytes in TCP, and that will be given to the TCP, which is going to store it in the buffer. And this TCP will be taking the bytes from the buffer and taking the set of bytes, it is going to construct the segment. Now the segment is going to contain the bytes as well as it is going to have the TCP header, and those segments will be forwarded towards the destination. Now in the destination, the segments will be, which is having the sequence of bytes, will be stored in the buffer, and TCP will be taking those bytes one by one. It is going to process and then it is going to forward to the application process. Now the flow control, as I already said, was the rate at which this TCP, okay, in the sending side is forwarding the bytes should not be so much that the receiver buffer, okay, if that the receiver buffer is full and the remaining bytes it is not able to store in its buffer. Now this sliding window, which is going to cover the set of bytes which can be transmitted by the sender TCP at a time, okay, is going to look like this. Let us say in the first example, the sliding window is covering 4 bytes, byte number 1, 2, 3, and 4. Okay, that means sender TCP can transmit these 4 bytes simultaneously. Maximum the 4 bytes sender TCP can transmit, that is byte 1, 2, 3, and 4 to the receiver side. Now, when they have transmitted these bytes, the sender TCP will be waiting to receive the acknowledgement for the bytes. Okay, so acknowledgement can be cumulative also. That means the receiver need not be sending the acknowledgement for each byte separately. Okay, let us say receiver received 2 bytes, and for both the byte, that is byte 1 and 2, receiver can send the acknowledgement. Okay, that is the acknowledgement number is going to be 3, which means that the receiver is expecting to receive byte number 3 next. So let us say sender received the acknowledgement for 2 bytes, which means that these are the bytes, okay, which sender had transmitted and sender received the acknowledgement also. That means receiver has received successfully. So once it is done, the window will be moved towards right. Okay, so that means since here in this example, the size of window is 4, so previously there was byte number 3 and 4, now it is also going to include byte number 5 and 6. Okay, so again byte number 3, 4, 5, 6, sender can transmit through the network towards the destination. Now when the sender will be receiving the acknowledgement, again this window will be moved. So after some time, we can see here the location of window is somewhere here, which is covering byte 9, 10, 11, and 12. Now the important points that we need to see here is the window is going to have two walls, one in the left side, one in the right side. Okay, so this wall is called left wall and this is called right wall. Okay? And in case of TCP, okay, this window is of variable size. Like for example, now the size of the window is 4. Okay, it can increase or it can decrease also. Okay, so how the size of the window is going to change, that as I said we will be discussing in the subsequent slides. Remember here, this is the left wall, this is the right wall, and a window at any point in time can be in any one of this mode. That is, a window can be in opened mode, it can be in closed, or it can be in shrunk. Okay, so opened is when the right wall moves towards right. Okay, let us say I have this window and this particular wall is moving towards the right. Let us say it is covering, previously it was covering byte 1, 2, 3, 4. Now it is covering byte 5 as well as 6. So when this is moving towards right, okay, we saw that we say that the window now is in the opened mode. Now closed is when the left wall, this left wall moves towards right. So when the left wall will be moving towards right is when sender TCP receives the acknowledgement for some of the bytes. So in this example, when sender TCP received the acknowledgement for byte 1 and 2, it moved this left wall towards right. Okay, so this is called closed mode. And the last one is shrunk. Okay, shrunk is when the right wall moves towards left. So which means that previously the bytes that was eligible to be transmitted was byte 1, 2, 3, 4. Now suppose if I move this right wall towards left, let us see if I place this right wall at this point, which means that I'm revoking the eligibility of byte 3 and 4 for transmission. So which means that I will not be allowed to transmit byte 3 and 4 through the network. Okay, so the same thing we can see here. Let us say these are the bytes that is there in the buffer of sending TCP. Okay, whenever we are opening this window, it means we are moving this right wall towards right, which is going to include more bytes. Whenever we are closing the window, it means we are moving this left wall towards right, which means for those bytes, sender TCP received the acknowledgement, so it need not worry further about those bytes. And shrinking means when we are moving this right wall towards left, which means that there was this bytes, okay, previously was eligible to be transmitted, now they cannot be transmitted. So actually shrinking is not acceptable in many of the applications. Okay, but sometimes we may need to do, and that is mainly because of congestion problem. Now, what will be the size of window? As I said, in case of TCP, the size of the window is variable. Okay, so it may increase or decrease. That is going to be based on the network as well as on the receiver. Okay, so sender itself cannot decide about the size of the window. Like in case of data link layer, sender used to decide about the size of the window, but here in this case, the size of the window, though window is acting in the sender TCP, but this size of the window will be decided by the network as well as by the receiver. Okay, so here the size of the window is equals to minimum of receiver's window size and congestion window size. So this receiver window size means in the receiver you have a buffer. So in that buffer, how many remaining bytes are vacant? Okay, so that buffer is capable of storing how many bytes next. So that is called receiver window. Let us say the size of the buffer is in the receiver, the size of the buffer is, let us say, 10 bytes. Okay, now receiver has already received 2 bytes. So it has already occupied 2 position in its buffer. Now receiver is left with 8 vacant position. So receiver now is capable to receive or store 8 bytes. So now at this point in time, the receiver window size will be equals to 8. Okay, so receiver window means how many bytes receiver now can store in its buffer. Now, what is this congestion window size? So this congestion window size is nothing but the network's window size. So how many bytes the network at this point in time is capable of carrying. Okay, it is capable of storing in its buffer and forwarding towards the receiver. So that is called congestion window size. So how this congestion window size will be calculated in the network, again, this we will be discussing in the next topic. Okay, for that we are going to have another video. Up till here, I hope it is clear to all. So the window size in the sender side will be equals to the minimum of how many bytes the network is capable of carrying and how many bytes the receiver is capable of storing. So whichever is minimum, that will be equal to the window size in the sender. So as I said, window is going to cover the set of bytes which sender TCP can transmit. So window size is going to govern how many bytes sender TCP can transmit at a time through the network towards the receiver. Okay, so how, as I said that window size will be equal to minimum of receiver window and congestion window. So how the receiver window size will be informed by receiver to the sender is in the acknowledgement packet. So sender, the whatever segment it is sending to the receiver, for that segment receiver is going to send the acknowledgement. Okay, so acknowledgement also is going to have the same header. Okay, the format is same as that of segment, wherein there is one field called window size. Okay, so this window size is when the receiver will be sending acknowledgement, receiver will be calculating how much of buffer space is left. Okay, so how many bytes receiver can store next in its buffer. Okay, so that is called window size. So receiver is going to calculate this window size and it is going to store that window size here, and then it is going to forward that towards the sender. Okay, so initially sender will be transmitting one segment, it will be storing in the buffer, and then receiver will be determining how many spaces are left, and that is called window size, that will be stored in the acknowledgement packet, and acknowledgement will be sent towards the sender. So here will be the use of the window size. So this we have already discussed, that sliding window is used for the flow control by TCP, so as not to overwhelm the receiver as well as not to overwhelm the network. And this sliding window in TCP is byte oriented. So some of the example we will have to see before proceeding further. Let us say, what is the value of receiver window for the host A if the receiver host B has buffer size of 500 byte and 100 bytes of received and unprocessed data. Okay, which means that receiver has received 100 bytes of the data and the total size of receiver's buffer is 500 byte, which means that when that receiver will be sending the acknowledgement packet, in that acknowledgement packet, what will be the window size value? Okay, so that is going to be 500 minus 1000. 4000 bytes are vacant, okay, wherein the incoming bytes can be stored by the receiver. Next is, what is the size of the window for host A if the value of receiver window is 3000 byte and value of congestion window is 3500 byte. So receiver can store 3000 bytes and network can transmit 3500 bytes simultaneously. So which means that what will be the size of sender's window? Okay, what should be the size of sender's window? It should be equal to minimum of receiver's window and the congestion window. So that is minimum of 3000 bytes and 3500 bytes, which will be equal to 3000 bytes. So this is an example we'll discuss from here, that let us say we have a window, sender's window, which is covering byte number starting from 200 to 208. Okay, so that means all the bytes before this 200, that is up to 199, sender has already transmitted, and for that sender has already got the acknowledgement also. So that means this For these bytes, sender TCP need not worry. Okay. Now, all the bytes that is after this byte number 208, that is starting from 209 to remaining, those are the bytes that is there in the sender's buffer, but sender now is not allowed to transmit those bytes. Okay, if they transmit those bytes also, then there will be congestion in the network, or there will be congestion in the destination, wherein the remaining bytes will be dropped by the network or by the destination. Now, inside this window, these are the bytes, okay, which sender TCP can transmit. Okay, so let us say sender TCP has transmitted byte 201, 200, 201, and 202. Okay, so up till here, these are the bytes which are sent but not acknowledgement, and these are the bytes, okay, which can be sent, but sender TCP has not transmitted till now, because for the set of bytes, it will have to construct the segment, and then the segment will be transmitted. So they can be sent immediately. Now, what is the window size? Let us say the congestion window size is 20 byte and receiver window size is 9 byte, which means that window size is going to be minimum of 20 and 9, which is equal to 9. So it is covering the 9 number of bytes. So some of the points that we need to remember is size of the window is lesser of receiver window and congestion window. The sender does not have to send full windows, okay, that is the entire packet starting from 208 200 to 208 simultaneously need not be transmitted. The window can be opened or closed. It can also be shrunk, okay, the reason we discussed previously. Destination can send acknowledgement at any time, okay. Remember that acknowledgement for each byte need not be transmitted. Cumulative acknowledgement can be used so as to reduce the number of acknowledgement packet in the network. The receiver can temporarily shut down the window. The sender, however, can always send segment of 1 byte after window is shut down. So receiver can decide to completely make window size 0. Now, once sender receives this information, sender still can send 1 more byte to the receiver. Okay, so the reasons we'll discuss later on. Okay, so remaining we will be discussing in the next video.